So here we go. Today's lesson, I would say, is not one of my favorite lessons to teach. There's not a lot of depth to it, but you do have to cover it. Not a real big reason why, but we do see some of these pieces pop up in the future in calculus. You already know how to do some of this. One's very intuitive anyway. But so here we go. We want to learn about the inverse trigonometric functions. And so you know about the sine function, but you know about the arc sine function. And it really looks like this, arc sine of x. And it's the same thing as, you've seen it maybe in its other state, sine inverse of x. Do those look familiar? The top one? So we've used that key on your calculator when we did chapter 6. Which makes me feel like they should have had this section before chapter 6. You know what I mean? That's when they teach you how to use the key. They teach you how to do the operation, but they don't teach you about the function. It is a function. And so that's the part we're going to discover. So I'm going to, this lesson starts out confusing, and then it gets much more clear at the end. So this function from negative pi to pi and negative 1 to 1 would look something like this. We've learned how to graph these over the course of past couple months. And the domain of a sine function is all real numbers. What is the range of the sine function? Negative 1 is the smallest value, and positive 1 is the largest value. Is everybody satisfied with that? Then we want to talk about the inverse. Arc sine is the inverse of sine. If you remember, when we had an equation, say y equals 3x plus 5, first semester, and I said find the inverse of that function, what would you do to find the inverse? Switch the x and the y values. So the domain and the range would also switch. So this range is going to become the domain up here. Our domain for the arc sine is going to be from negative 1 to positive 1. To discover the range, because the range is not all real numbers, there's a reason why, you'll see, we have to think about how we get these values. All right. I'm going to try teaching this a little bit different than I did the previous hour, because people have always been confused with this. This coordinate right here, actually, I'm sorry, I'm not going to look at that one. I'm going to start it as a height of 1, so I'm going to focus on this coordinate right there. That is a coordinate of pi over 2, 1, correct? So therefore, what will be the coordinate of arc sine? 1 pi over 2, correct? So the domain will go from negative 1 to positive 1. Looks like we have a value of pi over 2. We can assume we would probably have a negative pi over 2 there as well. So 1 pi over 2 is the coordinate. Here, sine has a value of 0. Sine of 0 is 0. So therefore, arc sine will go through 0, 0. This coordinate down here is negative pi over 2, negative 1. So therefore, arc sine will have a coordinate of negative 1, negative pi over 2. And that's what we get. So that range just goes from negative pi over 2 to positive pi over 2. Watch. Graphically speaking, we'll say that that's the line. That was a really bad job. doesn't really look like that. Okay. If I were to flip this graph over the line y equals x, I would get something that looks like this. Okay. Is that green line a function? No. So when it says an inverse trig function, we flip part of it, but we can't continue on. That's why we restrict the range to only this. If we said all real numbers for the range, it would continue to move back and forth, and that would not be a function. So, the first thing that I need you to be able to do is to understand, do you know why this is a segment and this is not? Like, or this is segmented. It's just a portion, and this is not. That's the most important piece. Take out your calculator. You guys know my friend named Haley Harms? Say hi, Haley. So good to see you today, Haley. Just can't get enough mathematics? Is that the deal? Coming to get your food, your leftovers. Share with your softball team. Have a great spring break. All right, so I'm going to type in, first of all, I'm going to be in mode. I'm working in radians. Y equals, I'm going to type in sine of x. And I'm also going to type in second sine inverse of x. And I'm going to restrict my window. Let's just go -2, +2, and -2, +2. Sine inverse. And as I graph this, you can see the sine function, which we graphed, and then you can see this, kind of segmented portion of the inverse. So, number one key is just to recognize that arc sine is that kind of strange thing, okay? Can you live with that? So if you graph it someday, you'll be like, oh yeah, I remember Mr. Gant's class, we had that once upon a time. That's it. Okay, we move along. Let's look at cosine. The cosine function. 1, -1. Negative pi, positive pi. That is the cosine function. So the domain is all real numbers. The range is again from -1 to +1. These we expect to switch, but again we run into that problem where if we put all real numbers for the range, we wouldn't get a function. Therefore, we must limit it to this segmented portion. The range, the range, the range. Let's figure it out. Okay. The cosine of pi gives you what? -1. So therefore, the arc cosine of -1 gives you pi. So, as we mark -1 and 1, this will be pi. Arc cosine of -1 gives us pi. So we have -1 pi is our coordinate. This is pi over 2. The cosine of pi over 2 gives you, what's the 0? So therefore, the arc cosine of 0 gives you pi over 2. So if you plug in 0, you get pi over 2. And finally, the cosine of 0 gives you 1. Therefore, the arc cosine of 1 is 0. That's so we get that kind of graph. So you can see the domain is from -1 to +1, but the range in this situation is from 0 to pi. Now, there's some interesting pieces as we think about some of the others. Arc cotangent, for example. For tangent of x, the domain is going to be all real numbers. You can plug anything and get the tangent, except for tangent is undefined halfway between the period, right? So let's say pi over 2. So x can't be pi over 2 plus 2k pi is how they write it. Don't worry about writing this down. You don't need to know this. But the idea is that you get these undefined values for pi every once in a while. So there are some values you can't plug in for tangent. However, the range for tangent is all real numbers. You could get any number out. Well, what does that mean for arc cotangent? That would mean that the domain is all real numbers. You can plug in any number for arc cotangent. However, there are some very specific values that you can't get out. We don't have to go that in depth because we just really don't have the time, okay? So we're going to cut to the chase and just see exactly what you have to know moving forward. Sine and cosine go on forever in each direction, but do their inverses? No, segment and portion. Also, when you press your calculator, you get some of these special values. So as you take out your calculator, now I want you to switch it to degrees. Go into mode and switch it over to degrees. Type in sine of 0.5. So as we type it in, we're going to check it against what we have, okay? Well, I'm sorry, not sine of 0.5. Sine inverse of 0.5. So is 0.5 within our domain? Yes. So I should get an output. The output should be between -90 and +90. It is. Let's try something else. Sine inverse of -0.5. Is -0.5 in our domain? So the output should be between -90 and +90. And it is. What is something outside the domain of sine? Yeah, sine inverse sine of -2, and we obviously get it here, okay? So, look at the difference, though, with cosine. If I go cosine inverse of 0.5, is 0.5 within the domain? The output should be between 0 and 180. It is. If you try the cosine inverse of -0.5, still within the domain, the output still between 0 and 180. Can sine come up with 120? Can sine inverse come up with 120? It can't. It's between -90 and +90 the whole time. So the second piece I want you to see under the graphs is, do you see why your calculator gives you the values it does? It's because of what we've specified here. Your calculator can't say, oh, well, sine's equal to 0.5 at 30, but also at 150. So they're at two different spots. It can only come up with one because it wants that function value, okay? So I'll show you what you will do for the first part of your assignment. You will punch in values. Take out your unit circle sheet for your notes so you can follow along. We're not going to do those. No, 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 no. Sine inverse of 1/2. Look at your unit circle sheet. Where is sine equal to 1/2 on your unit circle? 30 degrees and 150. Now, those just happen to be the spots between 0 and 360 where it's equal to 1/2. Now, which one of these is your calculator going to come up with if you press sine inverse? 30, because it can only come up with values between negative 90 and positive 90. So the sine inverse of 1/2, you would just want to write 30. 150 is not the correct answer. Tangent inverse of -1. Where is tangent inverse equal to, or where is tangent equal to -1 on your calculator? Or on your, yeah, 135 and 315. But when you plug it in on your calculator and you go tangent inverse of -1, you can see that you get actually -45. That's because the range of arctan is between -90 and positive 90. Either one of these is between -90 and positive 90. So that's why you get this. I'm just trying to help you understand. You might be like, oh, I thought it would come up with 135. No. Yeah. If you, yes, that's wrong. If I asked you to do tangent inverse of -1, the correct answer is -45. Now, that said, to understand really why it's wrong, tangent's equal to -1, 315. But we will never really use that value as we move forward to the next section. We like this one, and we like that one. That's what we use. And I'll show you why when we get to section 7.5. So there's a big portion that comes after this that makes sense of what we're doing. That's when we're solving trig equations. Look at the next one. Can you take the cosine inverse of 3? No. There's no solution there. Look on your sheet. Where is cosine equal to -√3/2? Yeah, it is. 150 degrees and 210 degrees. As you look at the range for cosine inverse, it says it's between 0 and 180. So which one is our calculator going to give us? It's going to give us the 150. And if you actually try that, second cosine inverse of -√3 divided by 2, you can see that it does in fact come up with the 150. So, yes. Plug it into your calculator. That's it. Yep. No, you could just simply, you don't even, you just, for your assignment, all I want you to do is just do the inverse key on your calculator. Why I'm doing this right now is I want you to understand that there's more than one spot where it's equal to that. Okay? It's kind of like this. What number do you square to get 4? 2 but your calculator only gives you the positive one. We're talking about the principal root. So it's kind of the same idea here. Your calculator can only come up with one of them. And that, because that's what it means to be a function. Okay, so now I get to show you a really cool part. You're going to love this. Don't write this down because you won't need to. Sine inverse of 1/2. Okay? These are inverses. What do inverses do to each other? They cancel. So what is the sine of sine inverse of 1/2? It's a half. What do I get there? Here's a trick one. Can you take the sine inverse of 4? You can't take the sine inverse of 4, can you? So this one has no solution. Can you take the sine of 4? Yeah. You can take sine of anything you want to. So in this situation, it will cancel and give you 4. Okay? Because you can't take sine inverse of 4. You plug in your calculator, you get no answer. Okay. So basically, inverse operations will cancel each other out. Now, when they don't cancel each other out is on your backside, and this will be kind of the more challenging part of your assignment. Still not that difficult. But what if we have the sine of the cosine inverse of 1/2? When we went through all these problems, it says evaluate the expression by sketching a triangle. We're going to use a triangle sketch to be able to simplify these best. Cosine inverse of 1/2. That means cosine, yeah, it's a 60-degree angle. And then the sine of 60 is the square root of 3/2. However, that's because we know it's a special value. But what if it's 4/5? So we're going to show you how to use a triangle to find the exact value rather quickly. And here's how you do it. We sketch a triangle. Dominic said when you take the cosine inverse of 1/2, you come up with 60 degrees, which is basically just the angle, correct? I'm not even going to write 60 because this is an easy example. We'll wait till we get to a more difficult one. What I do is I draw the parts of my triangle. Cosine is adjacent divided by hypotenuse. So that means that the angle right here has an adjacent side of 1 and a hypotenuse of length 2. Is that enough information to solve for the third side of the triangle? Yes, and I can just use the Pythagorean theorem. A squared plus b squared is equal to c squared. So b is equal to the root of 3. So let's then show exactly what Dominic said. He said if you do cosine inverse of 1/2, you get whatever the angle is, correct? You get theta. Looking at the drawing, what is sine of theta? It is the opposite divided by the hypotenuse. It is the square root of 3/2. So the sine of cosine inverse of 1/2 is the square root of 3/2. Yeah. Yes. Yeah. Doing his mathematics. Who does math? Come on. All right. Next one. I draw my shape. Right triangle. Theta. Sine is opposite over hypotenuse. We have 4 there and we have 5 there. Is that enough information to find the other side of the triangle? What is it? 3. Because it's a 3, 4, 5 triangle. 3 squared plus 4 squared is 5 squared. So as I work this out, I take the cotangent of sine inverse of 4/5. Well, when I do sine inverse of 4/5, what part of the triangle do I get? Starts with a th, rhymes with eta. Get theta. So when you sine inverse 4/5, you come up with the angle. You come up with theta. Well, what is cotangent? Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So it's 3/4. Mm-hmm. Always. Some people don't like secant, so I'll change the problem. I'll do tangent of cosine instead of 3. What should I write if I'm going to do cosine? 1/3. So tangent of cosine inverse of 1/3, because secant and cosine are reciprocals. So I'm going to go ahead and make a drawing today. Put theta right there. Cosine is what? SOHCAHTOA. What is it? Adjacent over hypotenuse. So it's 1 and 3. Is that enough information to find the other side? Yes, 1 squared plus b squared is equal to 9. So b is equal to the square root of 8, or 2 roots of 2. Remember when we used to spend 2 days to figure that out? You know what I mean? Now, we've got that. Tangent of cosine inverse of 1/3. What's cosine inverse of 1/3? What part of the triangle does it give you? Theta. So this turns into tangent of theta, which is 2 roots of 2. And the last one. I have theta. I have a 90-degree angle. Cotangent. What? So I got tangent inverse of 5 over 12. So the opposite side is 5. The adjacent side is 12. What's the hypotenuse? This is another Pythagorean triple, right? 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. You memorize these, right? Okay. We've talked about this. You just get a poster board. You write all them down. You buy yourself a bunk bed. And you just stick them in the ceiling. That way, when you fall asleep each night, you just fall asleep looking at mathematics. And then you just remember it all. Okay? Because then you'll be closer to it. You can actually... All right. Yeah, that's a great idea. Put it on your windshield when you drive. Never mind. Yeah. So you get cosecant of theta. Cosecant is the inverse of sine. What would sine be? Sine would be 5 over 13. So cosecant is 13 over 5. So, folks, that's what I've got for you. I've got an assignment. And it doesn't take very long. As a matter of fact, you'll be able to finish a lot of it before you leave today. 1 through 4, just use your calculator, confirm with your unit circle sheet, and answer in degrees. 13 through 18, easy stuff. And then 29 through 34, sketch the triangles. Sure it is.